Okay, guys. So this is called synthetic division.
Depends on the design.
But not just synthetic division, we're also going to start connecting this to graphing as well. Okay, because that's where we're going with this. It's not an isolated thing, it's connected to somebody. So the first example, this is where I'll explain in detail how to do synthetic division. After that, we'll just kind of go through it faster, okay? So this example will be very detailed. Let's have 2x squared plus 7x plus 9 divided by x plus 2. Okay. Now, before we jump in there and do synthetic division, let's extract the information we know from this. Okay, there's a lot of information we can extract. This is standard form. It's not factored form. You don't have the parentheses, okay? With standard form, you don't add the powers. The highest power tells you what it is. Even though this is the power of 1, I don't add it. Okay, so this is a degree 2. Okay, highest power dominates. So that means it's going to look like that. Okay, before I even start, I know what this will look like. That means both the right arm, and the left arm, they're both pointing up towards infinity. Up, up. Question, gentlemen? They're both pointing up. The other part I know is the y-intercept as well. So don't look at the divided part. That's why I just underlined the trinomial there. What would the y-intercept be on this one? 9. Okay, because you plug a 0 in here, that's 0. Plug a 0 in here, that's 0. So there's your y-intercept. A lot of information. Okay. So for all y-intercepts, no matter what equation, no matter the form, you plug a 0 into the x. So check this out. 0 squared is 0. 0 times 2. So that cancels out. 0 plus 7. 0. So the only thing left is 9. So that's not part of the equation. We're about to divide. Is it recording?
I think so.
Yeah. Okay. Okay, so here we go, guys. Synthetic division. Okay. Here's what you do. Y'all keep an eye on that if it stops recording for whatever reason. Okay, you make this box. Okay. It's like an upside down box. And then whatever power you start with, that's what order you'll do it in. Okay, so x2, after x2 comes x1, and then after x1 comes a constant, which is you're going to put a number. So if I had started with x to the 4th, I would do 4, 3, 2, 1. You get what I'm saying? You just work your way down. Okay. Each spot has to have a number though. Okay, so here we go. The number for x squared is 2. The number for 7, and then that's 9. Right there where I put the numbers, you don't put x's, just numbers, just the numbers. Okay. All right, and then I'm going to divide it by this. Now, this is in the form of a factor. I'm going to put question mark, okay, and I'll show you why I put a question mark there. But we don't divide by the factor, we divide by the root. Question mark, okay. That's actually the whole reason we're dividing, is to see if that is a root. So if that's the factor, what's the root of that factor, guys? -2. It's the opposite. Okay, they're always the opposites. Factors and roots. Okay, here we go. Okay, here's the process for synthetic division. You drop down the first number. By the way, there's another form of division that's called long division. I don't know if we'll do it, but just know there's different kinds. This is the fastest one. That's why we do this one. Okay. So drop down the 2, or that first number, whatever that first number is, and then you're going to multiply those two. Multiply. Since these are your notes and they should be very clear to you, you might put that this is the opposite. It's always the opposite. If that was a +5, you'd be divided by -5. If that was a -5, you'd be divided by 5. The opposite. Always, always. Okay, anyway, you drop that number, multiply. The result of multiplying those two goes there. So -2 times 2 is -4. And then you're gonna, all these will add. You're always adding, never subtract, okay? So I add 7 plus -4. Your biggest enemy with these is again gonna be your signs. So if you know that you tend to add and subtract positive, negative numbers wrong here and there, double check your work, okay? All right, and then you just follow this pattern. Multiply. Okay. -2 times 3 is -6. Add. Multiply, add, multiply, add, multiply, add. And so that's 3. And there it is. We just synthetic divided something, okay? Now we have to learn how to interpret our answer, but that's the process. You just drop the first one, multiply, add, multiply, add, multiply, add. Okay, any questions right now, guys, that you guys have? You all kind of remember doing this or no? A little bit, no? Something. Okay, this last number is a big deal. Okay, put it in a box. This last number is called your remainder. Now this is really, really important. Okay, I have to do it up like this. I don't have space, but you could fit this on the side. Okay, what does the remainder mean? It's your leftover, but it has a meaning for this specifically. Let me see how to word it. If remainder equals 0, it is a root. That's a big deal, okay? So if I say that backwards, that means that, remember what we divided by this root, question mark, x equals -2? That means x equals -2, that's not 0, it is not a x, root means x-intercept, so that means that this is not a x-intercept. Had this equaled 0, that would be a x-intercept, because that's what another word for x-intercept is 0, okay? So the whole purpose of dividing, the reason we're doing this is that a root? Let's say touch the x-axis there. How do we know that? If that's 0. Okay, that's the reason. Okay. Okay, that kind of summarizes the whole synthetic division process. Question? No? Okay, I'm going to separate this from the examples so that when you watch it,